Okay, welcome to lecture 15. So in this lecture, we're going to keep working on balancing and writing out kinds of reactions. So reactions to show us what's happening in some sort of chemical change. What materials are we starting with? Those are called the reactants. What materials we're making? Those materials are called the products. So what we're going to do again is look at how we have to keep track of atoms, right? The number of atoms that you start with has to be the same as the number of atoms you end with. So that's called balancing. And then also we're going to learn that, yeah, in nature, there's several types of reactions that are common. So different categories of reactions. We'll also be looking at that. So with that, let's go ahead and get started. And kind of like we did last time, we're going to start off by watching let's see if I can get this to switch. Give me a second here. Actually, before we get to the reaction, let's do a quick review of what we looked at last time. So last time when we were talking about types of reactions, we learned about two types, right? One type is called a combination reaction. So in a combination reaction, two things join together to make one product. So you start off with two reactants, two substances. They could be two different elements, or they could even be two different compounds, and they join together to make one thing. So they're joining together. So it's kind of like they're getting married to each other. Oh, how sweet. They are getting married to each other. They're joining together. So if you end up with two things combining, that is a combination reaction. Now, the other kind of reaction we looked at last time was called a decomposition reaction. So a decomposition reaction, it's the opposite. One thing breaks apart. So again, it's sort of like the opposite of a marriage. It's a divorce. We start off with a little family, a little happy family, and it splits into two, or it could even be more, pieces. So if you have a compound and it splits up into two things, that's called decomposition. It's the opposite of a combination reaction. All right, with that, let's get into a new example. So in this new example, we're going to look at, again, a reaction. And I'm going to show it to you. I'm going to play a video of it. And then after we watch what this reaction looks like, we're going to hopefully be able to write out what actually occurred in the reaction that we're seeing. So let me go ahead and see if we can play it here. So, in this reaction, they're going to take magnesium and carbon dioxide. Now, I should tell you, the carbon dioxide they use is actually solid carbon dioxide. Carbon dioxide, when it's a solid, we call that dry ice. So you'll hear it be called dry ice in the movie. So let's go ahead and see what happens when we do this reaction. Magnesium and carbon dioxide. Let me go ahead and play it.
Magnesium is placed in a cavity in a block of dry ice. The magnesium is ignited.
All right, so they're heating up that magnesium.
And covered with another block of dry ice.
All right, carbon dioxide, really, right?
Despite the absence of air, the magnesium continues to glow due to its reaction with carbon dioxide. Because of this reaction, carbon dioxide cannot be used to extinguish magnesium fires.
Wow, so you can see it gave off a lot of energy, a lot of heat there, pretty big reaction. What did we make? What did we make? What's the products? Let's look at them.
The reaction products are white magnesium oxide and black carbon.
All right. Magnesium oxide and carbon. So the black stuff is carbon. All right, so let's go ahead, and now that we've seen that reaction, let's try to write it out. All right, so I'm going to flip to another slide here, and we're going to see if we can write out this reaction. Okay, so, I got to click over here. Oh, didn't mean that. There we go. All right, so I'm doing this recording slightly different than I normally do, so I have to get used to the settings again. Okay, so we took magnesium and we reacted with carbon dioxide. The products they told us in the movie were magnesium oxide, and we also made carbon. All right, so the very first thing we're going to have to do, we're going to need to write out the formulas of these things, right? So that's all like what we heard about in the past, writing formulas. You know, if it's ionic, there's charges and all that, right? So let's go ahead, and before we write out and try to balance this equation, we got to know the formulas of these things. So let's start off with the very first one, magnesium. Actually, magnesium is just an element. What's the symbol for magnesium? Oh, I hope you know, it's Mg. All right. And then I got to write plus carbon dioxide. So what's the formula for carbon dioxide? Oh, I hope you know, it's CO2. All right. And then we're going to write the formulas of the stuff we created. So the stuff we created was magnesium oxide. So carbon dioxide, I didn't really worry about looking at the periodic table, because remember, the subscripts or the prefixes tell me the subscripts. So it's molecular, isn't it? Carbon dioxide. Now, when we get to the right-hand side, though, and I ask you about magnesium oxide, what kind of compound is that? Magnesium oxide. That's ionic. We have to think about charges. So magnesium oxide, an ionic compound. Oh, how did that work? Magnesium, its charge was +2. And what's the charge on oxygen? Well, let's see. How did that work again? This was -1. This was -2. It's in the -2 column. Remember, oh, I should have written this in here. +1, +2, all those old charges that we had to remember. So magnesium is +2. Oxygen is -2. So when they get together, the right formula should just be MgO. All right, so magnesium oxide, that's the formula for magnesium oxide. And then the other product is carbon. So carbon, the symbol for carbon is just the element carbon, it's C. All right, so those are our compounds. That's what we started with on the left-hand side, the reactants. What we're making on the right-hand side, that's called the products. So what we're going to do next is we're going to try to make sure the number of atoms on both sides matching up. When nature does a reaction, if she starts with some atoms, she's got to end with the exact same number of atoms. So now that we know what's going on, what stuff we started with and what stuff we made, we got to keep track of those atoms. So the way we do that, we might need to put in coefficients. Coefficients can go in front of formulas. So there's 4 possible spots for them, right? So in any of those places I put a line, you could write a coefficient if you need to. All right, now to see if we really need one, let's keep track of our atoms. So I'm going to make a little list. Left-hand side, you know, if you don't see a subscript, it's a 1. 1 magnesium. Left-hand side, oh, if you don't see a subscript, it's a 1. 1 carbon, 2 oxygens. All right, the 2 goes with the oxygen. So what about on the right-hand side? 1 magnesium. All right, how many oxygens are there? Just the 1, right? Just that one right there. 1 oxygen. And then how many carbons? Oh, just the 1 carbon. Should look like that. All right, so what we're going to do next is, well, anything that's not matching up, we got to fix it. So my problem right now, it looks like to me, is with oxygen. There's 2 on the left and only 1 on the right. So how am I going to get oxygen to balance? I think I need to put a 2 right here. That 2 would double everything in that formula. So it would be 2 times 1, 2 magnesiums. That's okay. But really the goal was, now I have 2 times 1, 2 oxygens. So oxygen is now balanced. There's 2 on the left, and because of that coefficient, there's also 2 on the right. Now, this often happens. We fixed oxygen, but we broke somebody else, the magnesium. So to fix the magnesium, we'll need to put in 1 more coefficient. There is 2 times 1, 2 magnesiums on the right. So to get 2 on the left, you put a 2 right here. All right, that 2 applies to only the magnesium. So now you would have 2 magnesiums. And I think everything matches up. You can double check if you don't believe me, but I think it is balanced now. Everything's got the same amount. All right, so that's called balancing. Balancing reactions involves putting in those coefficients where you need them to get the number of atoms to match up. All right, one more thing. We're also going to learn about kinds of reactions. So this is another category. This is not combination. This is not decomposition. This is a single replacement reaction. A single replacement reaction. What does that mean? It basically means one element is replacing another in a compound. All right. So this would be an example, one way to think about this is to kind of think about it generically. We could say element A reacts with BC. So BC would be some compound, right? B and C joined together, like element B and element C. And what happens is element A kicks out B, B gets thrown out, and it takes its place. So we end up with AC, A moves in, and B gets thrown out. All right. So again, I think of chemistry, it's really just relationships, right? It's really just, it's like people, how people interact. Combination, that's getting married, joining together. Decomposition, that's a divorce, you're breaking up. So this is sort of like, oh, to me, this is sort of like a sad one. Like we have a happy family here, a happy little group of atoms, carbon and oxygen. Maybe it could be like, I don't know, me and my wife, a little happy family, all right? And then along comes, I don't know, Brad Pitt. Brad Pitt comes along. And what happens is Brad kicks me out and he takes my place. So me, I guess I'm the carbon in this, I get thrown out of my family. Wow, I don't like the sound of this at all. I get thrown out of my family and instead Brad and my wife are together. Oh, that's so sad. All right. So it's kind of like, oh, a relationship gone bad. Somebody is taking your place in your family. Oh, we don't want that, do we? All right. So with that, that's called a single replacement. So that's the end of part 8. Maybe we should do one little question here, one little practice question. Okay, with that, we're going to stop and we'll move on to part B. We'll be looking at yet another kind of reaction in part B. All right.